Partial with respect to x. Well, does this have any x's in it? No, so it's just going to be that, isn't it? Partial of that with respect to x. That's the first piece. Then partial with respect to y. Well, this doesn't have any y's in it either. So it'll just be the partial of that with respect to y. And then the partial with respect to z. Well, that doesn't have z's in it, but that does. But what's that equal to? The partial of that with respect to z. -1. Right? Because you solved for z. We're saying if you start with this, you'll always have minus z over here. So you'll always have -1. Anyways, I'm just showing you that this is a generalization, is a specific instance of the formula that we just looked at. All right, where are we at? How are we doing on time? I think I'm done with 11.6. Oh, no. Okay, this one. Find the equation of the normal line to the tangent plane of the ellipsoid. What? Find the equation of the normal line. What the hell is a normal line? We don't know yet, and we haven't even talked about it, have we? We haven't talked about a normal line. So is that the same ellipsoid we were just looking at? Yeah. Same point? Yes. Yep. So we got this ellipsoid, this egg-shaped thing, and we just had a point there, and we found the equation of the plane that runs tangent to that, right? Okay, what we want to find now is what's called the normal line. So if you give me any plane, okay, any plane, and you give me a point on that plane, you have to give me a point, then I can find the equation of a line that punches through that point and is perpendicular to the plane. That's called the normal line. So what do you need to define, the vector equation of a line? What do you need for the vector equation of a line? Any line. You need a point and a direction vector, right? You need a point, really that point's going to turn to a vector, and then you need a direction vector. Those are the things you need, right, to define a line? All right, do you have a point? So I'm trying to imagine a line that goes through this, right? This line goes through this, right, whatever, and it's orthogonal to the plane. So do you have a point on there? Okay, what's your point? I'm using this formula right here. I'm using the vector equation, the generic formula for the line. Like that, right? So do we know or not? Yeah, that's the point, right? We were given that. -3, 4, 5. Plus t times, do we have a direction vector? Do we have a vector that lives on this line and points in the direction of that? The normal vector of the plane, right? The normal vector of the plane would work. And we already calculated that, didn't we? I erased it. 8 2/5, yeah, that's right. There we go. That is the vector equation of the line that is normal to that plane.
So what's the difference between the normal vector and the normal line?
The normal vector. Okay, so the normal vector is just a vector, right? And remember, vectors can be moved around, right? The line is actually a formula that if I plug in different values of t, I'm going to draw every single point on this line forever, right?
So for the normal line, we require a knot, right?
Yes. Yes, because we're trying to find the equation of a line, right? The equation of a line. And in this class, the equation of a line is this. And so you need a starting point, which we actually convert to a vector. Okay, and since that's the point that we were talking about, that's the point here. And then for any line, right, you need the point and you need a direction vector. Any vector that points in the direction of the line. But since this is a normal line, it needs to be running in the same direction as the normal vector for the plane. And you could have used any scalar multiple of this, by the way. You could have scaled that and it would have worked. Okay, so I'm going to do something that I don't normally do in this class. We're going to stop right here. Okay, we're going to end class right now. All right, and then what I'll do is I'll just entertain any questions that you might have over anything. If not, you're free to go. Right, that'll be the end of the week for us, right? Okay. We're not ahead. Okay, we're not ahead, and I'm like, let's just. But the next section, I want everyone to come in fresh on Monday, be ready to roll, because the next two sections. Well, the next section is going to be okay. The one after that is historically a section people hate. Not hate, they love it, but they realize just how much they don't know about solving equations and things. It's a lot of things to keep track of. It's called Lagrange multipliers. So it's just really kind of messy. So I want you to come in fresh on Monday. We'll get through 11.7. We'll get through 11.7 on Monday. This is going to be just, we're going to be just finally doing something with all this. We're going to look at surfaces. We're going to try and find their highest and lowest points. Right? Give me a surface. Can we find these, hilltops and valleys? Just like we did in Cal 1, trying to find the peaks and valleys of a curve on a two-dimensional sheet of paper. How hard is it for us to do that in three-dimensional space? It actually turns out that we have things like we did in Cal 1. We have tests that we do, and we check to see if this is positive, then it's doing this. If it's negative, it's doing that. But we have to develop a lot of different formulas and stuff, and we'll get into it. All right, we'll get into it. All right. I think one other thing another reason I want to stop is because if I don't slow down, Lagrange is going to wind up on your exam, and I don't think you want Lagrange on the midterm. I think you want Lagrange on the final. That's just my opinion. So we slow down just a little bit. And we'll knock this section out. This section right here, 11.7, is going to take us 2 days. It's going to take us 2 days. So that'll push us in the next week. And that means the following Monday, the week of your midterm, that Monday, I will start Lagrange, but we will not test on it. Does that make sense? So all of next week will be this section. It's just, since this takes an entire week to do, I'm not going to start it now. But I'll hang out for a little bit. If you have any questions, I'll entertain them. I will be in my office hours later, though. Otherwise, have a good weekend. Study for everything, your other classes as well.
When is the midterm again?
2 weeks from today. 2 weeks from today.